Now that we've seen the 5 main symbols in this section, negation, conjunction, disjunction, conditional, and biconditional, we're ready to mix them all together into something called a truth table. Sections 3.3 and 3.4 are all about truth tables. And a truth table is just simply a device that's used to determine when a statement is true or false. So this is not like a philosophy course where there are shades of gray. In this chapter, everything is either fact or it's a lie. Think of like a lawyer. It's right or it's wrong. So starting with a truth table for the negation symbol, if we consider an idea, I'll call it P, and we are going to literally make tables in this section. If we have an idea in math, it could either be true, so I'm going to put a capital T for true, or that idea could be false. It has to be one or the other. I'll put a capital F for false. So if I bring in the negation symbol, that was that tilde, that squiggle, and I apply the negation to my P, well, looking at the top row first, if I negate a true statement, it's going to make it false. Looking at the bottom row now, if I negate a false truth value, so each box we call that a truth value, if I negate a false, it's going to make it true. So from here on out, when we deal with the more complicated truth tables, whenever you see that negation symbol, it just means do the opposite. It works like a negative symbol in algebra where it would change the sign. So if we negate a true, it becomes false. If we negate a false, it becomes true in our truth tables. The second symbol is the conjunction symbol. So let's see what effects, what answers that and conjunction is going to produce on a truth table and why. So the conjunction was the up arrow. We read that out loud as the word and. It also represents the words but, however, and nevertheless. They're all types of a conjunction. As our example, to see what's going to happen with the word and inside a truth table, it says you purchase a new carpet and new furniture. The salesperson states, quote, the carpet will be delivered on Thursday and the furniture will be delivered on Friday. Create a truth table to see when the salesperson has kept his or her promise. Before we can analyze that statement made by the salesperson and make the truth table, we have a couple steps to do first. So step 1 is always going to be to assign letters to represent each of the ideas that you're analyzing. Now, I've already done that first step for you. So step 1 is right up here with the black pen in my messy handwriting. I already have let P represent the idea that the carpet's going to come on Thursday, and let Q represent the idea that the furniture is going to come on Friday. Step 2, now that we've assigned letters to represent each of the ideas that we're analyzing, we go through the sentence again and we bring in the symbols and the letters all together. So the first part of the statement is carpet will be delivered on Thursday, which we're using the letter P to represent. We then hit the word and, which is the up arrow. After that, it says the furniture will be delivered on Friday, which is the letter Q. So really, mathematically speaking, when it asks us to create a truth table, we're going to create an entire truth table for P and Q. Step 3 is the actual truth table step, what we wanted all along. And this is our first example where we see a truth table with 2 different letters, with 2 different ideas. Each unique letter gets its own column always. So P will have its own column, Q will have its own column, Whatever you want the truth table to be about, that will be the last column heading every single time. So in this case, we said that we want the truth table to be for P and Q. So I'm going to bring down that as my final column heading. Most of your homework truth table problems and most of your test truth table problems will have two different letters. There are 4 scenarios that could play out whenever you have two different letters. Both of those letters, those ideas, could come true. So TT will always be your first row. The first idea, P, could come true, whereas Q could be false. So TF will always be the second row. The third row, vice versa. P could be false, Q could be true. And finally, the fourth row, both ideas could be lies and be false. That's just setting up the truth table. So every single time you have a P and a Q, the first row will be TT, the second row will be TF, the third row will be FT, and the fourth and final row will be FF. This part will already be filled in for you on the My Math Lab homework. So all of the work is going to really be underneath that column on the right-hand side. As I look at that final column, I always do any arrows in the middle last, at least if there are no parentheses, and we're not seeing parentheses yet. So going from left to right, my first step, the first thing I see is the letter P. This means I need to copy and paste the P column all over, just like it's an Excel spreadsheet. So as I look at the P column, I see T, T, F, F. So bring it on over, T, T, F, F. Try to keep it lined up underneath the letter P. Again, just like it's an Excel spreadsheet. Since we do the arrow in the middle last, step 2 is going to be the letter Q. And letter Q, now we're going to copy and paste the Q column over as is. Right now it's TF, TF. So slide it on over, TF, TF. And finally, that up arrow, the and, we're going to apply it to what's on either side of it. Thinking about the context of what it means in this question, we're going to be able to discover how the and arrow is going to play out in all of the future truth tables. Line 1, this and is surrounded by 2 T's. So if P is true and Q is true, that means the carpet does come on Thursday and the furniture does come on Friday. So if the salesperson says to you, I promise that carpet is coming on Thursday and that furniture is coming on Friday, and both items do come true, well, the salesperson has told the truth. So the final answer in that row is a T. So we just saw that 2 T's make another T. 2 trues make another true when you're dealing with an and. Line 2. P is true, but Q is false. If P is true, that means that the carpet does come on Thursday. However, if Q is false, that means that the furniture, though, does not arrive on Friday. And is a very strict word, and you'll see these kind of analyzing of semantics and wording in the legal realms a lot. So when people are writing contracts about how money will be distributed, like with wills, they have to be very careful what word choices they use. So legally, in real life, if you use the word and, you have to be very, very careful, and we're going to see why here. Because if just one item is not upholded, if just one item does not come true, you've lied. You're not upholding your end of the bargain. So if that furniture does not come on Friday and you say, I promise this and this, well, you've lied. So the whole thing is false. Looking at line 3, it says P is false now, but Q is true. If P is false, the carpet does not come on Thursday. However, the furniture arrives on time on Friday. But same logic as the previous row. If the salesperson says, I promise, carpet's on Thursday, furniture's on Friday, but the carpet does not come on Thursday, he or she has lied. So this ends up being another false. And finally, the last row, the bottom row, we have P is false and Q is false. So in other words, the carpet does not come on Thursday and the furniture does not come on Friday. If you're promising two items, because you're using the word and, you're definitely lying here if neither item holds true. So the final answers, the most important column, are under the and symbol. If I rewrite it from left to right, it's what I have in blue. T, F, F, and F would be the final answers. What this means for us here on out is every single time you see an up arrow, an and arrow, in a more complicated truth table, the only time you get an answer of true is if that up arrow is surrounded by two T's. So true and another true gives you a true. So this is the only time we get an answer of true. However, if you look at all the other rows, if you have at least one F, so if you have one or two F's around an up arrow, the final answer is going to be false. The third symbol we discussed in the previous two videos, that now we have to see what happens when we have it in a truth table, was the disjunction. That was the down arrow for or. Again, let's take a look at an example so we can understand why it produces the answers it's going to produce. It says someone is applying for a job. The job application states that the applicant must have a 2-year degree in civil technology, or he or she must have 5 years of related job experience. Construct a truth table to see if someone qualifies for the job. First step I did not do for you in this time. So we got to assign letters to represent all the ideas we're analyzing. So this is step 1. So the job application, the first idea it mentions is that the applicant must have the 2-year degree in civil technology. So I'm going to let P equal, and I'm just going to summarize it as 2-year degree. The second item after the word or says the applicant or they can have 5 years of related job experience. So I'm going to let Q represent the 5 years of experience. Now that we've assigned letters to represent all the ideas, step 2, we can go back through the sentence we're analyzing and bring in the symbols and the letters all together. First item was about that the applicant has to have that 2-year degree, so that was letter P. Then we see the word or, which is the down arrow, the disjunction down arrow. Then it mentions or they can have the 5 years of experience, so that was letter Q. So really, I'm going to create a truth table that's all about P or Q. Step 3 is the actual truth table step. For each letter we see, it needs its own column. So there's the P column and the Q column. And whatever you're making the truth table be about, that's the last column heading, P or Q. That's where all the work is going to go. We need to set up our truth table. The first row will always be true, true, so both ideas could be true. The second row will always be TF. The third row will always be FT. And the fourth row will always be FF. We're listing every possible scenario that could play out. Now, just getting in the habit to prepare for the larger, more complicated truth tables that are to come. Remember, we do the arrow in the middle last. That's where all the final answers go. So step 1, I'll do in red. As I go from left to right, I see the letter P first again, which means to copy and paste the P column on over, which is T, T, F, F. Since we're doing the arrow in the middle last, step 2, just plain old letter Q. So copy and paste now the Q column over, which is TF, TF. Now we get to explore what's going to happen with the or. I'm going to change to a blue pen. Step 3 right here. And we apply that arrow to what's on either side of it. Looking at row 1, I have 2 T's, a T on either side of it, which means that the applicant that wants the job does have the 2-year degree, and he or she does have the 5 years of experience. So could they possibly get the job if the application says they have to have the degree or the experience? Well, sure. They have both, so they definitely could potentially interview and get the job. So that's going to be a true. So 2 T's make another T whenever you see the down or in a truth table. Row 2, P is true and Q is false. So it's true that the person does have the 2-year degree, but they do not have the 5 years of experience. Now, or is much more lenient than the word and. If the application just says, let me go ahead and erase this a little bit. But if the application just says, hey, we're happy with either the 2-year degree or the 5 years of experience, and someone has just the degree, that's enough that that person, that candidate, could potentially get the job. So if you have just one false, it doesn't matter. So just at least one true makes a true. That's the key difference between the and up arrow that we just did on the last slide versus the down arrow or. The same is going to be true in row 3. So row 3, now P is false, but Q is true. So if P is false, the candidate does not have the degree. Q is true. He or she does have the experience. Yeah, they could still get the job because just one or the other is good enough. You could have one or the other or both is what the word or means in this chapter. The only time that person could not get the job is row 4. 2 false statements. P is false and Q is false. So the person does not have the degree, nor does he or she have the experience. If they have to have at least one, that's what or means in this chapter, then it's false. My final answer in blue is T, 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 F. From here on out, whenever you see the down arrow or, the only time the whole thing is false is when you have 2 F's surrounding that down arrow. So 2 F's make an F. If you have at least one true, the whole thing is true. Very different than the up arrow and. Now let's see how the 4th symbol is going to play out in a truth table. The 4th symbol is the conditional, which was the if-then arrow pointing to the right. So it says to construct a truth table for the following quote. If you get an A in this mathematics course, then I will buy you a car. So very extreme example. I am not actually promising anybody a car. I just wanted an extreme example just so we could analyze it a little bit easier. So let's go through our 3 steps yet again. So before I can make up the truth table, I need to figure out the letters. So we assign letters to represent each of the ideas we're going to be analyzing. So P, the first idea is you get an A in this math course. So you get an A in math. I'll summarize it as, the second idea, Q, is I will buy you a car. Now that we've assigned letters to represent all the ideas in the sentence we're analyzing, step 2, we go through the sentence again and bring in the symbols with the letters. So I see the words if, then, which means I need the arrow, the conditional arrow pointing to the right. In the if portion is you get an A in this math course, which was letter P. So P goes on the left side of the arrow. In the then portion of the sentence, I will buy you a car, was the letter Q. So if P, then Q is what we're going to make the truth table be about. Step 3 is the actual truth table step. P gets its own column again. Q gets its own column again. Whatever we want the truth table to be about is the last column heading. We want it to be about if P, then Q. And let's set up our truth table. So TT, then TF always, FT, or FF, or all the possible scenarios that could play out. We leave the arrow in the middle for last. So on the far left, I see the letter P yet again. So that means copy and paste the P column over, which is TTFF. TTFF. Gonna erase a little bit. Next up, since we're leaving the arrow in the middle for last, I see just a normal Q, so now I'm going to copy and paste the Q column over, which is TF. And finally, the final answers, the part we really care about, is what's going to happen with this if-then arrow. It's a little bit trickier. So let's start with row 1. I have two T's. P is true and Q is true. You're always applying the arrow to what's on either side of it. So if P is true, that means that you do get the A in math. If Q is also true, then I did in fact buy you the car. So if I promised you, if you get an A in this math course, then I'm buying you a car, you got the A in math, I followed through, I bought you the car, we produce another true statement. I've told the truth. So two T's, yet again, make a true. Row 2. Row 2, P is true, so you do get the A in math, check. However, Q is false. I don't buy you the car. Well, I've lied, so that's false, because if I say, if you do something, then I will do this for you, but I don't follow through on the then portion, I've clearly lied. I should have bought you the car because you did get the A in math. Now be very careful with rows 3 and 4. These are trickier with the if-then arrow. They're easy to make a mistake with. If P is false and Q is true. So let's think about that. P is false, so you don't get the A in math. However, Q is true, I bought you the car anyway. Well, if my promise is, if you get an A in math, then I'm buying you the car. If you never got the A in math to begin with, then who cares what I do? Who cares if I don't buy you the car or if I buy you 20 cars? The whole point is that you have to come through with the if portion of the deal for me to have either lied or told the truth. If you never come through with the if portion, then I've told the truth regardless. It would be like if I said, if pigs fly, then I will wake up 6 feet tall tomorrow. Well, I can make that promise to you because pigs are never going to fly, and I've known that I've told the truth regardless. So surprisingly, if there's an F, on the left side of the arrow and a T on the right side, the whole thing is still true. And here's the really confusing one. The last row, 2 F's, are going to surprisingly make a true because of the same logic. Since you don't get the A in math, I never bought you the car, but again, you never upheld your end of the bargain. The if portion never came true, so who cares what I do? The point is I told the truth. The only time I've lied is in row 2. If you follow through with your end of the bargain and you did get the A in math, then I'm obligated to buy you the car based on my statement, based on my original promise. So the only time you're going to throw down an F when you see this if-then arrow is if you have a T on the left-hand side in the if portion of the arrow and you have an F on the right-hand side. That is going to be the only time you throw down the letter F. I did upload into your course a summary, by the way, of what all 5 symbols do in a truth table. So you might want to print that out and have that handy when you go to take the test on this and when you do the homework. That way you can just simply look up what each symbol produces in a truth table when we get to the more complicated truth tables, such as in the next video. Last but not least, the 5th symbol, the biconditional, which is a type of conditional. It's the double arrowhead. It relates to if and only if. We're going to use what we learned in the last slide. So before we start this, just recall we said with a normal conditional, an if-then arrow, that T pointing to T was true. We said the only time we get a false was row 2, where if we have a T on the left and an F on the right. If you have an F on the left-hand side, doesn't matter what's on the right-hand side, you're always going to say true. And 2 F's, that means also makes it true. So let's keep that in mind and build off of that definition to do a truth table with the biconditional. So let's say we have our P, we have our Q. I don't have a word problem to analyze, a statement to analyze, so I'm just going to jump right into the truth table. I'm going to do the truth table for the double arrow, the biconditional. The setup's the same. We got 2 T's, or we could have TF, or we could have F first, then T, or I could have 2 F's. The homework's already going to have that part set up and ready to go for you. We do the arrow in the middle last. So step 1, I'm going to copy and paste the P column over, which is TTFF. Since I'm leaving the arrow for last as usual, step 2 is the Q column. Copy and paste that over, which is TFTF. Might have it memorized. We've already done a bunch of these now. And here we go with our last new symbol in a truth table, the biconditional. So I'm on the lookout for this scenario since it's a type of conditional. I'm looking for T on the left side of the arrow and the arrowhead pointing to an F because I know that's the only time I'm going to throw down an F. If I look at row 1, I'm going from a true to a true, checking backwards. I'm going again from T to T, so that makes a true. Now let's check line 2. So line 2, I'm going from T to an F, so already starting with a T and pointing to an F with any type of conditional is going to produce a false. Now looking at row 3, if I start with an F and point to a T, didn't mean to get rid of some of my pen there. Okay, let's try this again. If I'm starting with an F and I point to a T, that's okay. That produces a true. However, going backwards, I got to check both directions. That's what the biconditional means. If I go backwards, I'm starting with a T and I'm pointing to an F, which is what I don't want. That's line 2. So starting with a T, pointing to an F when I check backwards. In other words, when I go this direction with a conditional, is going to produce a false. So here's where it is different from a normal conditional. An F on the left side is going to produce a false with the biconditional. And finally, two F's. Well, F pointing to another F, that's okay. Two F's with any type of conditional make it true. And likewise, going backwards, starting with F, pointing to F again, we get a true. So this box that I'm circling was the only difference between the conditional versus the biconditional. So my final answers in blue, T, F, F, and T. A memory trick that you're welcome to use is that you'll notice when the truth values on either side match, the final answer is a true. So, like row 1, I had 2 T's and it made a true. Bottom row, 2 F's. The answers matched and I got a true again. So my memory trick for the biconditional is that matches equals a true. Whereas when you had one of each, 1 T, 1 F, or 1 F, 1 T in the two middle rows, you ended up with a false. So a mismatch, one of each, in other words, is going to give you a false statement. Some people think of that matches memory trick like when you're multiplying signs in algebra. If you're multiplying a positive times another positive, you end up with a positive or a true statement. If you multiply a negative times a negative, you also end up with a positive number. So matches in that regard gave you a positive answer or a true. Whereas if you had one of each sign and you're multiplying in algebra, you got a negative number. So a positive times a negative or negative times a positive, either way, one of each, a mismatch, gave you a negative number or a false.